Hi, I'm Rendell Heyman, a mathematics academic. Welcome to my Corona Help playlist where I make quick turnaround videos to help students and educators during the virus outbreak. If you'd like me to make a video for you, totally ad-free I might add, then just comment below any of my videos, or if you like, you can drop me an email. So someone's asked me to have a look at this problem. So this is an abstract algebra problem, but it turns out it's got some number theory embedded in it. So let's just talk about what we've got here. I mean, MZ, here we want to sort of, you might think M is just an integer. So, 2Z, which is all the even numbers, or 7Z, which is all the numbers, positive and negative, that are divisible by 7. So that's just the set, ... minus M, 0, M, 2M, ... etc. And we'd normally just have addition and multiplication as the two operations of the ring that we're involved in there. Now the same for N. Now MN is just an abbreviation for the GCD, the greatest common divisor of M and N. One of the, as I do more teaching of maths and also reflect on the maths that I, that I did when I was studying, one of the big problems is variations in the notation. It really does cause a lot of problems. Anyway, we have to live with what we have to live with. So that just means GCD. So so what is this really saying? This is saying that a multiple of M plus a multiple of N is equal to a multiple of the GCD of M and N. So the thing that we need for this is, well, let's just do an example, a thinking example, just to think this through. 2Z, let's think about 2Z plus 3Z. So we've got all the even numbers, -4, -2, -2, 0, 2, 4, ... And we've also got 3Z, which is ... -9, -6, -3, 0, 3, 6, ... So that one's that one, and that one's that one. Now, if we were going to add these up, we can basically get to any number we want. I mean, if you think about it, here's any even number. And, these are basically, well, if you look at any even number, let's just take 0, 1, 2, 3, 4, 5, 6. This is not a good way to explain it, really. Or is it? Well, I suppose, I'm not sure if this does explain it. 0, if you've got the numbers 0, 1, 2, 3, 4, 5, you get rid of the even numbers because you don't even need this bit to create that. And then here, you've got, we could go on, I suppose. Here you've got this number's divisible by 3. This number is neither divisible by 3 or 2, but it's just a combination. And the same with this. So I'm not explaining it very well, but if you just try it out like this, you'll see that you can easily create any number you want by adding up an even number and a number divisible by 3. So let's rub that out because I haven't really brilliantly explained that. But it is a good idea with these things to just play around with a specific concrete example first. But the thing that you need is this thing, Bezout's. It's called Bezout's identity, or sometimes it's called Bezout's lemma, or even the theorem, which says, basically for any A and B, so A and B just integers, we can find x, y such that A times x plus B times y equals the GCD of A and B. So this is saying for any AB, you can always find some combination of the two and add them up. Or you can always find a multiple of A plus a multiple of B, add them up, and you'll get the GCD of A and B. And moreover, for every x and y, AX plus BY will be a multiple of GCD A and B. So not only can you create the GCD by multiples of A and B and then adding them up, but you can also create every multiple of the GCD. And in fact, you can't get anything but the multiples of GCD, the GCD of A and B. So if you're interested in this, looking at this a bit further, for example, I've got a couple of videos. One's called RSA Code Made Easy. And another one is modular inverse. I think this one's got a modular inverse made easy. Anyway, in both of these, I asked the question, I want to construct the number 1 from multiples of 3,197. And the GCD of 3,197 is 1. And sure enough, there is a way that you can actually go about finding how to construct the number 1 as a addition of a multiple of 3,000 and a multiple of 197. So that's not so easy to do if you don't know the trick, called the extended Euclidean algorithm. Okay, so now let's return to the problem that I asked from America, which was, well, I've got up there. So, so what have we got? We've got, so MZ plus NZ is the addition of every possible multiple of M with every possible multiple of N. So by Bezout's identity, MZ plus NZ is the set, or the ring, I suppose, the set of multiples of GCD, the GCD of M and N. Therefore, so that's just saying that MZ plus NZ equals GCD of MN, which in the notation that was from the problem is just that. Actually, sorry, I should put another Z or Z there. So let's do that. So it's the GCD of MN times Z, which is equal to just that. Okay, so I hope that's helped. If you've got any questions, as per usual, just let me know. Just a little note, actually, before I go, every so often I like to do a video, every 50 videos or so, I like to do a video that's just something a bit different, a bit fun, a bit interesting. So I'm hoping to do very soon a video on, with the title Maths Isn't, or Mathematics Isn't Science. And I'll have a mathematical philosopher on board with me on that, and we'll have a chat about that. So keep an eye out for that. But as per normal, any problems in maths during the coronavirus outbreak, please email me or contact me by commenting below any of my videos.